This is an introduction to linear systems of equations. There are 5 things we want to discuss in this lesson. First, vocabulary. Second, identifying if a point is a solution to a linear system. Third, use a graphical approach to solving linear systems of equations. 4, know and understand the 3 types of linear systems. And lastly, finding a solution to linear systems of equations from tables. There are a few vocabulary words I want you to know. Feel free to pause the video at any time, especially at the end, to make sure that you have all the vocabulary words down. First, linear systems of equations. That is just 2 or more linear equations. Solution to a system of equations. This is just a set of solutions that satisfy 2 or more equations. A consistent system. That's a system that only has one solution. So when a system of equations only has one solution. An inconsistent system. That is a system of equation that has no solution. And an example of that would be parallel lines. And lastly, a dependent system. A dependent system is a system when there are infinite solutions. And the only time you can have infinite solutions is when the 2 lines are actually the exact same line. So now let's get into a word problem so we can see how system of equations actually work. Crystal, who owns a small business, is comparing phone plans with internet access bundled in. Each plan she looks at is quoting her the per month charges. The first plan she looks at states that the internet access costs $30 plus $12 per line. The second plan she examines costs $24 for internet access plus $15 per line. A. Find the equations for the monthly cost in dollars of bundled internet access and phone for each plan. Let X represent the number of phone lines required. First thing we want to notice, $30 plus $12 per line. So our equation, first our expression will start off 30 plus $12. The 3-letter word per lets you know you're going to then multiply it by your variable. So then times X. So let's look at the next phone plan. $24 for internet access plus $15 per line. So our equation would be Y equals 24 plus 15 times X. Since we now have 2 equations, we now have a system of equations. Let's plot some points. And before we plot points, we need to fill in our table. So if X, or the number of lines, is 0, and in this case we have X is actually represented by N in this box here. So X is the number of lines. If X is 0, then Y is 30. If x is 1, y is 42. If x is 2, 2 times 12 is 24, plus 30, 54. And so on, and so on. For our blue equation, y equals 15x plus 24. If x is 0, 15 times 0 is 0 plus 24 is 24. If x is 1, 15 times 1 is 15 plus 24 is 39. And as we continue to plug in these numbers, when you plug in 2 for x, when you plug in 3 for x, and when you plug in 4 for x, we now have ordered pair, 5 ordered pair for the first, the red graph, and 5 ordered pair for the second, the blue graph. C, for how many phone lines is the cost going to be the same? Well, if we look at where the cost is the same, here and here, we can see that for 2 phone lines, the cost is the same. D, if Crystal has 4 phone lines, which plan should she use? Well, if you look at the 4 phone lines, you either have a bill of $78, or a monthly cost of $78, or a monthly cost of $84. Well, if Crystal has a business, she probably wants to pay less rather than paying more. So Crystal should go with Plan 1. Now, let's check the solution for each system of equations. We want to check to see if the point 1, 4 is a solution to the system. So what we do is we take the value for x and the value for y, so x is 1, y is 4, and plug them into both equations. When we do that, for the first equation, we have 2 times 1 plus 4 equals 6. That's true. And for the second equation, plug in 1 for x and 4 for y. You have 1 minus 4 times 4, that equal 12? No. In order for a solution, or for a point to be a solution, it must be true for both equations. So the point 1, 4 is not a solution to the linear system of equations. Now let's check the point 4, negative 2. When you plug in 4 for x and negative 2 for y in the first equation, we get, and 2 times 4 plus negative 2 is 6. Check. Plug 4 in for x and negative 2 in for y for the second equation. 4 minus 4 times negative 2. Well, 4 times negative 2 is negative 8. So 4 minus negative 8 is positive 12. Check. Since the ordered pair works and gives you a correct answer for both equations, then the point 4, negative 2 is a solution to the linear systems of equations. Let's find the solution to linear systems of equations by graphing. Now, we graphed back in AFM 092, so I will not spend an enormous amount of time graphing. I will cover the basics. So since both of these graphs are in slope-intercept form, I'm going to first plot the y-intercept. So let's look at the first graph, the red graph. The y-intercept is 0, -1. That's because the b in this equation is -1. So I must first plot the point 0, -1. The slope in this equation is 3. So I must go up 3 and over 1 and then place my second point and connect my dots and draw my line. For the red graph, what is the y-intercept? Zero, -4. 0, 4. So I first plot the point 0, 4, and my slope is -2. So I go down 2 and to the right 1. Connect my dots and draw my line. So now you can see that the solution to the linear systems of equation is the point 1, 2. Looking at tables and trying to find the solution to the system of equations. This here is pretty simple to identify. There's only one place where the x-coordinate and the y-coordinates are the same. That's the point 2, 4. So that is the solution to the linear system of equations. Remember, a solution to the linear system is the point where the x-coordinates and the y-coordinates are the same for both equations or for both tables. There are 3 types of linear systems. There's the first type where you only have one solution. One solution. And when you have one solution, we call this a consistent system. One solution for a linear system of equation means one solution. The second type is when you have parallel lines, or the 2 lines do not intersect. That's called an inconsistent system, and there are no solutions. Remember, a solution is where the 2 lines intersect or cross. Lastly, we have a system where we have one line and a second line exactly on top of it, which makes the 2 lines the same line. That's called a dependent system, and that has infinite solution. So remember, you only have 3 options for linear systems of equations: one solution, no solution, or infinite solutions. And those vocabulary words are consistent system, one solution; inconsistent system, no solution; dependent system, infinite solutions. Please make sure you start on my Math Lab 4.1 and read over any of the workbook slides from lesson 4.2 in preparation for the next video lecture. Thank you.